The lesson outcome for this video is I can multiply polynomials. In this video, we will talk about multiplying a monomial by some other type of polynomial, whether it is a binomial like this one and this one, or as you'll see on later screens, multiplying it by a trinomial or even a four-term polynomial. Okay, so you might remember that we've done some of this before. And the way we have multiplied a monomial, like 5, times a binomial, 3x minus 7, is using something called the distributive property, where we need to multiply the 5 by both terms in the parentheses. So when we do this, remember we need to multiply while we're doing this, and we're going to do 5 times 3x, which is 15x. And then we're going to multiply the 5 times the negative 7, so 5 times negative 7, which is negative 35. Okay, so again, this is the distributive property, and you are used to that strategy. In this second example, I'm going to show a different strategy that you can use. It is called an array. And you may have seen something like this before. An array is a series of, it's kind of like a table, I should say. It's kind of like a table, and if we're multiplying a one-term, a monomial, times two terms, we will need a 1 by 2 array. So I'm going to draw a 1 by 2 array. This is what it's going to look like. Okay, so what we're going to do is we're going to take the 4x and we're going to put it out on the left-hand side of the one row right here. Now we're going to take the 2x squared and the positive 3, and we're going to put those in these two spots in our two columns. So I'll put the 2x squared here and the positive 3 here. We don't need the sign if it's positive, but if it was negative, we would need to write a negative there. Now what we're going to do is we're going to multiply these two terms, and we're going to write it here. Then we're going to multiply these two terms, and we're going to put it here. Now when you're doing this multiplication, you need to think about the power rules that we learned in a previous unit. So when we multiply 4x times 2x squared, you don't have to write it out every time, but I'm going to show you that it looks like this: 4x times 2x squared. What you need to remember is that we can multiply these factors in any order we want. So we can multiply the 4 times the 2, so 4 times 2 is 8. We're going to write the 8 here. And then we need to multiply the x times the x squared. Remember that x is x to the first, and when we are multiplying an x to the first power, when we're multiplying an x to the first power times an x to the second power, we will add the exponents. So x to the first times x squared is x to the third. Then we're going to multiply 4x times 3. Again, you don't have to write this out, but just to look at it, 4x times 3, we can multiply the 4 times 3, which is 12, and then we have the x. Now, we should write our answer as a polynomial just like we did here. So we're going to write 8x to the third plus 12x. And remember, you cannot combine these. They are not like terms. They have different variable parts. So this is our answer to that multiplication problem. Again, this is the array method, and this is the distributive property. Notice they're doing the same thing. They are just using a different strategy to get there. So let's try these two examples. The first one says negative 9x to the fourth times 2x plus 3. Again, this will be an example of a monomial times a binomial, and if you want to use an array, you can. If you want to use the distributive property, you can. I'm going to continue to use the array method because I think it's going to help, especially as we learn our next lesson. So there's negative 9x to the fourth, and then we have 2x times 3. We're going to multiply these. So negative 9 times 2 is negative 18. And then we have x to the fourth times x, which is x to the fifth. Multiplying negative 9x to the fourth times 3. Negative 9 times 3 is negative 27. And we have x to the fourth. Writing our final answer is negative 18 x to the fifth minus 27x to the fourth. You could have also written plus negative 27x to the fourth right here. So adding a negative 27x to the fourth would be the same. Now this next one is a monomial times a four-term polynomial. So what kind of array would we need for this? We would need a 1 by 1, 2, 3, 4. So here's the array. We're going to need 1, 2, 3, 4 columns and 1 row. So 2x to the second, we'll have x to the third, 3x squared, positive 5x, and negative 3. So we're going to go ahead and multiply this times each and every one of these and put it in the corresponding rectangle below. 2x squared times x to the third. Well, we have 2. Now we have x squared times x to the third. Well, this would be x times x, this would be x times x times x. That altogether is x to the fifth. Now we have 2 times 3, which is 6, and then x squared times x squared is x to the fourth. 2x squared times 5x, 2 times 5 is 10, and x squared times x is x to the third. 2x squared times negative 3 is negative 6x squared. So our final polynomial for our answer is 2x to the fifth plus 6x to the fourth plus 10x to the third minus 6x squared. Notice all of these have different variable parts so that we can't combine them at all. That is our answer. For this last example, I'm going to ask that you pause the video, try this on your paper, and then check back to see how you did. But before you do so, I want to remind you that this problem is going to be able to be done the same exact way because multiplication is commutative. What I mean by that is there are 4 terms here multiplied by 1 term on the right. Normally this is over here. This problem can be solved the exact same way as the previous example, and in fact, if you wanted to, you could even write the 4x squared over here to make it seem more comfortable for you if you don't want it on the right. Whichever way you do it is fine. Go ahead, pause the video, try this problem on your own, and check to see how you did. Okay, so I'm still going to use a 1 by 4 array. I'm going to put my 4x squared here, and my 3x to the fourth, negative x squared, 2x, and negative 5. Now if you decided to make a 4 by 1 array, I want to show this quick. A 4 by 1 array is going to give you the exact same solution. So if you put 3x to the fourth minus x squared, 2x, and negative 5, and you multiply that by 4x squared, we will get the exact same solution. Maybe I'll go ahead and do this one on the right, the vertical one. So we have 3 times 4 is 12, and then we have x to the sixth. 12x to the sixth. Then we have a negative x squared times 4x squared. So negative 1 is right here. So negative 1 times 4 is negative 4. And then we have x squared times x squared, which is x to the fourth. We have 2x times 4x squared. So 2 times 4 is 8. X times x squared is x to the third. 8x to the third. And lastly, we have negative 5 times 4x squared, negative 20x squared. To write our final solution, this is what you should have got on your own if you tried it. No matter if you made your array horizontal or vertical, this is your answer when you multiply those two polynomials.